Hi, I'm James Graham, project leader.
Hi, I'm Dylan, camoufleur.
Hi, I'm Victor, the fabricator.
I'm Justin, the seat maker.
And Brett is filming.
And this is Liberty Legion, our cardboard canoe submission of the keg canoe.
How's it going, everybody? So I'm going to be going over the materials used. Our first material that we used is cardboard. Clearly you see here we went to Home Depot to got their cardboard boxes. Next off, we have duct tape. Just, the average gray duct tape. Then, as we have here, we got the box cutter, just simple box cutter. Then we have the ruler, as you see here, metal ruler, precise. Then we have our tape measure. We went with Stanley. And then here we got the Sharpie.
Hey, I'm Brett. Here's our prototype. We wanted to put something rough together, kind of see how it's going to work and make sure we can actually build something that would float. This is what we did the testing on. We'll just go over a little bit how we built it. We duct taped the outside completely, so there's no cardboard shown anywhere. And then on the insides, we reinforced the seams right there to make sure there wasn't any wire coming in. And these right here, they're supposed to simulate the seats. We altered that design a little bit. You'll hear about that in a minute. And then when we did the test, we completely filled up these. We had 2 of these and 1 of these, and we put it in there. We put it in the bathtub, and it actually held up all of it. And it actually sunk more due to the instability of it. So it leaned off to the right, I think, and it got water inside of it, and that caused it to tip over. But it was actually holding up all the jugs.
Alright, so I'm here to talk to you about the changes we made from the prototype to our main design. So we moved our seats back. The back one's going to be in the very back of the boat, and this front one's going to be in the center. We also angled the sides out. As you can see on our prototype, they're straight up and down. We angled them out to about a 35-degree angle so that we'll have a wider center of balance. We also changed our nose to make it more hydrodynamic. We used the Pike's nose so that it's going to angle up a little bit more. And it also is going to make it easier to make our angled sides come into our nose more smoothly. And then lastly, what we're going to do is right here on the back, we're going to put a fin on the back so our boat goes straight and we're not going sideways across the lake.
To decorate our ship, we will be using dazzle camouflage, which was popular in both World War I and World War II. The camouflage is meant to confuse enemy gunners and anybody trying to identify parts of the ship. But to do this, we'll be using black and white duct tape to candy stripe the entirety of the boat. And like the camouflage, we hope to dazzle our way to victory.
And this is the math that proves our ship is totally buoyant. F of B, or buoyancy force, is equal to the volume of water displaced times the density of water displaced. The volume will be equal to the area of the shape times the length of the boat. Boat times density of water, which is around 1,000 kilograms per meters cubed. The area of the boat, since it is a trapezoidal shape, is base 1 plus base 2 divided by 2 times height. Then the volume would be that area times length times for density, and with the nodal displacement being that times density of water. Our boat's lower area, or the base, would be about 0.45 meters. The top area is about 0.9 meters, but that divided by 2 times an overall height of about 0.45 meters times an overall length of about 2.2 meters gets us to about 0.668 meters cubed, more or less. That times 1,000 kilograms per meters cubed gets us to be right around 668 kilometers displaced, or in terms that the rest of us can actually understand, around 1,400 pounds. That is more than enough for a 2-man crew to go across the lake.